We discussed the TCP IP stack and the functions of the different layers in the stack in the previous lecture. This lecture continues that discussion and focuses on the TCP IP and UDP protocol architecture, service primitives and parameters, multimedia types, and sockets programming. Remember that TCP provides a reliable connection for the transfer of data between applications. A header is appended to the user data as we transmit it across the network. The TCP header format is shown here. It is a minimum of 20 octets, or 160 bits. In the header, the source port takes up 16 bits, and the destination port also takes up 16 bits. These fields identify the applications at the source and destination systems that are using this connection. The sequence number and acknowledgement number are each 32 bits long. These two fields, along with the window field, provide flow control and error control. There is also a 16-bit checksum used for error detection in the TCP segment. The other transport level protocol is the User Datagram Protocol, or UDP. UDP does not guarantee delivery, so it is a connectionless protocol. Because of this, we can see that the header does not have as many fields as how the TCP header has. The UDP header only consists of the source port, destination port, segment length, and checksum, each 16 bits in length. As we mentioned previously, besides TCP, the other transport level protocol is the User Datagram Protocol, or UDP. UDP is a connectionless protocol, and UDP does not guarantee delivery, preservation of sequence, or protection against duplication. It is used primarily for establishing low latency and loss-tolerating connections between applications on the internet, so it is common for voice and video traffic. Some transaction-oriented applications, such as SNMP, or Simple Network Management Protocol, make use of UDP. Although UDP includes a checksum to verify that no error occurs in the data, it is optional. Internet Protocol version 4, or IPv4, is the fourth version of the Internet Protocol, which defines IP addresses in a 32-bit format. It is one of the core protocols of the Internet and other packet-switched networks. The IPv4 header format also has a minimum of 20 octets, or 160 bits, just like the TCP header. This header, with the segment from the transport layer, forms an IP-level PDU, referred to as an IP datagram or an IP packet. The identification, flags, and fragment offset fields are used in the fragmentation and reassembly process. The time to live field tells a network router whether or not the packet has been in the network too long and should be discarded. The header checksum field is used to detect errors in the header to avoid misdelivery. Since IPv4 addresses are 32 bits in length, that's why we can see that the source and destination addresses in the header are 32 bits each. As of September 24, 2015, the free pool of IPv4 address space was depleted. IPv6 is the next generation Internet Protocol standard intended to eventually replace IPv4. IPv6 provides a number of functional enhancements over IPv4 and is designed to accommodate the higher speeds of today's networks and the mix of data streams, including graphic and video, that are becoming more prevalent. But the main reason behind the development of the new protocol was because of the need for more addresses since we ran out of IPv4 addresses. As we mentioned before, IPv4 uses a 32-bit address to specify a source or destination, but IPv6 uses a 128-bit source and destination address, as we can see from the header. Also, in IPv6, the time to live field in each packet has been renamed the hop limit. The TCP IP suite contains many different protocols. Most applications require a reliable end-to-end protocol and thus make use of TCP. These applications include File Transfer Protocol, or FTP, for insecure file transfer, Hypertext Transfer Protocol, or HTTP, which defines how messages are formatted and transmitted for the World Wide Web, Simple Mail Transfer Protocol, or SMTP, used to send email, and Secure Shell, or SSH, for operating network services securely over an unsecured network. Some applications, such as Simple Network Management Protocol, or SNMP, which is a way for different devices on a network to share information with one another, use UDP. Other applications, like Internet Control Message Protocol, or ICMP, which is an error reporting protocol, and Open Shortest Path First, OSPF, which is a routing protocol for IP networks, use IP directly. As we discussed before, the overall communications function can be broken down into layers to form the protocol architecture. Each layer has its own function, and changes in standards in one layer does not affect already existing software in another layer. Thus, the layers are independent of one another, and standards can be developed independently and simultaneously for each layer. At each layer, protocol specification can be defined, which includes which protocols can operate at a given layer. The service definition is also defined at each layer, which states which services each layer provides to the next higher layer. Finally, addressing by a port or service access point, or SAP, is defined at each layer. The services between adjacent layers in a protocol architecture are expressed in terms of primitives and parameters. A primitive specifies the function to be performed, and the parameters are used to pass data and control information. The actual form of a primitive is implementation dependent. An example of this is a procedure call. Four types of primitives are used in standards to define the interaction between adjacent layers in the architecture. A request invokes some service. An indication provides a notification that an action or procedure has been initiated. A response is an acknowledgement to an invoked procedure by an indication. Finally, a confirm is an acknowledgement to an invoked procedure by a request. From the four primitives mentioned previously, the sequence of events would determine if a service is confirmed or not. If the service user goes through all four primitives, which means that the service user performs a request, receives an indication from the service provider, and then sends a response to the service provider and receives a confirm from the service provider, then this means that the service is confirmed. However, if only the request and indication primitives are involved, then we have a non-confirmed service, because the service user never receives a confirmation that the requested action has taken place. Many applications operate on top of TCP, but the three most common ones are Simple Mail Transfer Protocol, or SMTP, File Transfer Protocol, or FTP, and Secure Shell, or SSH. SMTP is used for email, and it provides a mechanism for transferring messages among separate hosts. Features of SMTP include mailing lists, return receipts, and forwarding. FTP is used to send files from one system to another insecurely without the overhead of any headers or control information at the application level. SSH provides a secure remote logon capability which allows a user at a terminal or personal computer to log onto a remote computer and function as if directly connected to that computer. SSH also supports file transfer between the local host and a remote server and encrypts all traffic in both directions. Because of the availability of broadband access to the Internet, there have been an increased interest in web-based and Internet-based multimedia applications. Media refers to the form of information, including text, images, audio, and video. Multimedia refers to human-computer interaction involving the different types of media and storage devices used to store the content. Streaming media refers to multimedia files like audio and video that play immediately after a computer receives it from the web. The media content is consumed as it's delivered directly from the server, rather than waiting for it to be finished downloading before consuming. This diagram looks at multimedia from the perspective of three different dimensions: type of media, applications, and the technology required to support the applications. We have already talked about the types of media, but the applications use these different types of media. The various technologies help to support these media types and applications and allow them to be delivered to the user. Usually, the term multimedia refers to four distinct types of media: text, audio, graphics, and video. Text is information that can be entered via a keyboard and is directly readable and printable. Examples of text include text messaging, instant messaging, text or non-HTML email, chat rooms, and message boards. Text also includes data that can be stored in files in databases. Audio includes voice or speech and also telephony and related applications such as voicemail, audio teleconferencing, telemarketing, and music. The image service supports the communication of individual pictures, charts, or drawings. Images can be in vector graphics format like PDF files, or in raster graphics format, where an image is represented as pixels, such as the JPEG format. Video carries sequences of pictures in time. Basically, video makes use of a sequence of raster scan images. The Internet has always been used for information retrieval applications, email, and file transfers. Today, multimedia applications dominate the use of the Internet, especially streaming audio and video. These, along with computer gaming, are heavily used in the entertainment domain. Video conferencing, such as Skype or Zoom, and shared workspaces are used in the telecommunications domain. Interactive applications, such as virtual training environments and electronic books, are example applications in the information publishing and delivery domain. Many other domains make use of multimedia applications. We already talked about a few of them, such as the information systems applications that present information using multimedia, like information kiosks, electronic books, and multimedia expert systems. Entertainment systems applications include computer games. Communication systems applications support collaborative work like video conferencing. Business systems applications include business-oriented multimedia presentations, video brochures, and online shopping. Finally, educational systems applications include simulation and modeling applets, ebooks, and other online teaching support. A wide range of technologies is needed to support all of the different multimedia applications. Compression is important because video generates a large amount of traffic on a network. A streaming application delivered to many users magnifies the traffic. Therefore, compression helps to provide some savings on the traffic that is generated. Standards include JPEG for images and MPEG for video. Communications and networking technologies are needed to support high-volume multimedia traffic. Protocols like Real-Time Transport Protocol, or RTP, is important to assure that real-time traffic is received by the end user in a smooth, continuous stream. Quality of service, or QoS, helps to provide differing levels of service to different types of application traffic. The idea of sockets came about in the 1980s in the Unix environment. A socket is one endpoint of a two-way communication link between two programs running on a network. It is basically a way to talk to other computers. A socket is bound to a port number so that the TCP layer can identify the application that data is to be sent to. An endpoint is a combination of an IP address and a port number. Sockets can be constructed from within a program in a language such as C, Java, or Python, allowing the programmer to easily support networking functions and applications. The combination of a port value and an IP address forms a socket, which is unique throughout the Internet. The socket is used to define an application programming interface, or API, which is a generic communication interface for writing programs that use TCP or UDP. Sockets used for an API include the protocol as well as the IP address and port number in defining a unique socket. The sockets API recognizes two types of sockets: stream sockets and datagram sockets. Stream sockets make use of TCP, which provides a connection-oriented, reliable data transfer. Thus, all blocks of data are guaranteed for delivery and arrive in the order that they were sent with stream sockets. On the other hand, datagram sockets use UDP, so delivery is not guaranteed, nor is order necessarily preserved. A third type of socket provided by the Sockets API is raw sockets. Raw sockets allow direct access to lower layer protocols such as IP. If you were to perform socket programming, the table summarizes the core socket functions and system calls that include creating a socket, to listening on a socket, to accepting and connecting to a server. Other functions include sending and receiving data on both a stream and datagram socket. For example, the first step in using sockets is to create a new socket using the socket command. After a socket is created, it must have an address to listen to. The bind function can help us bind a socket to a socket address. From there, we can then perform other functions like listening, sending, and receiving. This wraps up Protocol Architectures, Multimedia Applications and Technologies, and Sockets Programming.